In this lesson, we want to talk about multiplying and dividing rational expressions. So in order to multiply and divide rational expressions, we need to think back to our basic math where we talked about multiplying and dividing fractions. So to get things started, let's just look at a very simple example, and then we will take this up a step and we'll think about rational expressions. So we have 1/4 times 2/7. How can we solve this problem? Well, basically what we could do is multiply across. So 1 times 2 is 2. And then 4 times 7 is 28. So basically numerator times numerator over denominator times denominator. But the problem with this is it's quite inefficient, right? If we just do this without trying to cancel anything, we end up with an unsimplified fraction. So we have to take the extra step now of simplifying. And basically you have a common factor of 2 there that you can cancel out. So 2 divided by 2 is 1. 28 divided by 2 is 14. So I get 1 over 14, okay, as my simplified result. Now, a more efficient way to do this, if we think about this, we would first make sure that each fraction, okay, in the multiplication problem is simplified already. So that means no common factors other than 1. So if I look at 1 and 4, we're good to go. If I look at 2 and 7, we're good to go. So nothing can be canceled there. Then I want to look to cross cancel. So in other words, I want to look here and I want to look here. Anything I can cancel? No. So then I want to look here and I want to look here. Anything I can cancel? Yes. 2 and 4 are both divisible by 2. If I divide 2 by 2, I get 1. If I divide 4 by 2, I get 2. Okay, so now once you've canceled everything, you can go through and multiply, and you're going to get a simplified result. So 1 times 1 now would give me 1, and 2 times 7 would give me 14. So now I have 1/14, and it's already simplified. So let's use the same strategy now when we're multiplying these rational expressions. We're going to think about simplifying each rational expression first, and then we're going to look to cross cancel. And once we've done both of those steps, then we want to move on and do some actual multiplication if it's necessary. In a lot of cases, so much stuff cancels, you don't even need to multiply. Now, before I actually do this problem, I want to make sure everybody's on the same page in terms of what can be canceled and what can't be canceled. This is quite confusing when you get into algebra. So if we have something like, let's say, 3 over 12, we know that we could write this as 3 over 3 times 2 times 2, okay? And then I can cancel this with this, right? I'm basically just saying 3 over 3 is 1, so I can cancel it out, right? So this ends up being just 1 over 4. Now, if you saw something like, let's say, 4 plus 3 over, let's say, 3, you should know, but you might not know, that you cannot cancel this 3 with this 3 like this. This is a very common error in algebra. You can only cancel common factors. If this was 4 times 3 like this, then you could cancel, okay? But if it's 4 plus 3 or 4 minus 3, you can't cancel. Think about this. 4 plus 3 is what? It's 7. 7 over 3 is not the same as if you canceled this and just got 4, okay? So please don't make that mistake. Now let's take this up a notch and think about this with something like this. Let's say I had x minus 1, this quantity, times, let's say, x plus 5, this quantity, and this was over, let's say, x minus 1 again, that quantity, and then times, let's say, x plus 6, this quantity. Now, a lot of people get confused here because you see there's a minus sign, a plus sign, a plus sign, a minus sign, and then when I start canceling stuff, they say, well, why can you cancel there? These are factors here, okay? This quantity here of x minus 1 is being multiplied by this quantity x plus 5. So these guys here are what we call factors, okay? They are being multiplied together. And so I can cancel common factors. So between the numerator and denominator, I have a common factor of x minus 1, so it can be canceled or removed. One way to see this for sure, let me just erase this real quick. If you thought about this, you could plug something in for x. You could just pick a number and plug it in. Let's say you picked 3, for example. Well, instead of x there, I would have a 3. Instead of x there, I would have a 3. Instead of x there, I would have a 3. Instead of x there, I would have a 3. Okay, so 3 minus 1 would be 2. So let's say we have 2 there. And then 3 plus 5 would be 8. So now we have 2 times 8. Here we'd have 3 minus 1, which is 2. Okay, we have 2. And here we have 3 plus 6, which is 9. So now it should be crystal clear to you that you can cancel this 2 with this 2, right? But where did that come from? That came from that common factor of x minus 1. So I hope that clears things up for you. Just pay close attention to what you're trying to cancel. It needs to be a common factor, okay? So with that being said, let's look at this first problem. We have 3x squared minus 2x minus 8 over 3x squared plus 14x plus 8. This is multiplied by 3x plus 2 over 3x plus 4. So again, what I want to do is think about factoring everything, simplifying between the rational expressions themselves, and then also trying to cross-cancel anything I can before I actually do any multiplication. So this guy right here and this guy right here, those are prime. You can't do anything with them. But for this one and this one, you can factor those, okay? So I'm going to use reverse FOIL here. If you're more comfortable with the AC method, that's fine too. So let's go ahead and set up some parentheses here. I'm going to do 3x and x because this is a prime number, okay? So that can only come from 3x and x. So all I have to do is work out what's going to go here and here. Now, I have 8 there. Forget about the fact that it's negative 8 for a moment and just think about 8. So 8 is 1 times 8 and it's 2 times 4. So 1 and 8, there's no way to make that work. But with 2 and 4, if you think about it, let's say you put a 4 here and a 2 here. Well, the outer would be 12x and the inner would be 2x. And don't worry about the signs just yet. This is not going to work, right? 12x and 2x, no matter how you play with the signs, that's not going to work. So let's think about the other configuration. Let's flip this. Let's put a 4 here and a 2 here. Well, now this would be 6x and this would be 4x, and I can make that work, right? If I made this negative and this positive, well, this would give me my negative 2x. And also, if I had a positive and a negative being multiplied together, I'd get my negative, okay? So what I want here is a negative here and a positive here, okay? So that would give me my 3x squared minus 2x minus 8. Okay, so moving on to the next one, let's go ahead and put our fraction bar. We have this guy here, so I'm going to factor it in a similar way. I'm going to do 3x, and I'm going to do x. And again, what's going to go here? Well, I have 8 once again, so it's only 1 and 8 or 2 and 4. So could I make this work with 1 and 8? Well, if I put 8 there, I would have 24x. That's going to be a little bit too big. If I put 8 here and 1 here, that's going to be too small. So 1 and 8, you can throw those out. That's not going to work. So if I put 4 here, I would have 12x. And then if I put 2 here, I would have 2x, so that looks like that would work, right? I want plus and plus, right? So the outer would be 12x, and the inner would be plus 2x, so that would combine to give me the 14x, and again, 2 times 4 is 8, so we're good to go there. So then let's multiply this by 3x plus 2 over 3x plus 4. So once you've factored everything, you've pretty much done, okay? This is the hardest part, or the most tedious part. If you're good at factoring, it's not hard at all. So let's come down here and see what we can cancel. Well, I have a common factor of 3x plus 2 here with here, okay? So if you're confused by this, you can always wrap this in parentheses and multiply it by 1. Okay, you don't have to do that. I'm just doing it to show you this. So you can cancel this with this. Those are, again, common factors. Then I'm looking at this 3x plus 4 and this 3x plus 4. So this cancels with this. So this right here is a big fat 1 now. It's completely canceled. So all I'm left with, if you want to solve this problem, is just take the x minus 2 over the x plus 4. And that's your simplified answer, okay? You don't need to do anything else. Things canceled, so you didn't even have to multiply. Okay, let's look at a more tedious problem. It's not harder, it's just more tedious. So we have x squared plus 9xy plus 14y squared over x squared plus 7xy plus 10y squared. This is now multiplied by x squared plus 2xy minus 15y squared over x squared minus xy minus 6y squared. Okay, so again, the first thing you want to do is factor everything and just try to cancel as much as you can. And if you have to, you're going to multiply. So what I'll do here, remember, these are meant to look scary, but they're actually not. So if you have an x squared here and a y squared here, just put an x and an x and a y and a y, right? X times x is x squared, y times y is y squared. Then forget about it. I'm going to do the same thing down here. So x, y, x, y. And if you want to, you can do this over here as well. So let's go ahead and set this up. So let's put these here, and I'll do x, 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 y, 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 y. And I'm sure those aren't going to be conducive to me fitting everything. So let me slide that down just a little bit more. And that might be too wide, but we'll adjust it as we need to. Okay, so for this one right here, it's really easy. Everything in terms of the leading coefficient is 1. So I'm just looking for two integers that sum to 9 and give me a product of 14. So that's 7 and 2, right? So plus 7 and plus 2, okay? Again, because you figured out that the y was there, you only have to work out this and this. That's it. So here, I've got 7 and I've got 10. So it's got to multiply to 10 and sum to 7. That's 5 and 2. So that's really easy. So 5 and 2. Here, it's got to sum to 2 and give me a product of negative 15. So that's going to be positive 5 and negative 3. So positive 5, and this isn't going to fit. So let's put x plus 5y and then x minus 3y. So positive 5 and negative 3. Okay, so for this one, we have -1, you could think of it as, and -6. So the product is going to be -6, the sum is going to be -1, so that's going to be -3 and +2. So -3 and +2. All right, let's see what we can cancel. So we have x plus 5y here that can be canceled with x plus 5y here. Again, we're canceling common factors, so things wrapped in parentheses. That's what we're looking for. X plus 2y here can be canceled with x plus 2y here. And then x minus 3y here can be canceled with x minus 3y here. Okay, so basically all you're left with is an x plus 7y. Let me scroll down and get some room so I can fit this. I'm going to put is equal to, I just have x plus 7y. That's my numerator. For the denominator, I'm just left with this x plus 2y. So again, in a lot of these cases, you don't even need to multiply because so much stuff's going to cancel. Okay, so we've done 2 with multiplication. Let's switch now to division, which is just as easy. So basically, we remember if we're dividing fractions, we keep the first fraction the same, we take the reciprocal of the second fraction, and then we multiply. So this guy is 6/11, so the first fraction stays the same. Change the division to multiplication, flip this guy, right? So the reciprocal, this goes up here, this comes down here. So I would basically have 33/4, okay? You can already see that this would cancel with this and give me a 3. This would cancel with this. So 6 divided by 2 is 3, and 4 divided by 2 is 2. So this is going to give me what? It's going to give me 3 times 3, which is 9, over just 2, right? Because this is 1, it's been canceled. So this is 1 times 2, or just 2. So the answer there is just 9/2. Very simple process. And we're going to do the same thing here. So we'll look at the x squared minus 9x plus 14 over 2x squared plus 3x minus 5 divided by x squared minus 2x minus 35 over x squared minus 4x plus 3. So however you want to do this, the first thing I'm going to do is just factor this one on the left. So I know that this is what? This is -9 and +14. So I need two integers that sum to -9, give me a product of +14. That's going to be -7 and -2. So x minus 7 and then x minus 2. Okay, so I've got that one. This one right here is a little bit harder to factor because this guy is not 1, but it's a prime number, so it's pretty quick, right? So I'm going to put 2x here and x here. Now, this last term here is -5. I'm just going to think about 5 for a second. 5 is only 1 and 5. Okay, it's 5 times 1 or 1 times 5, however you want to think about that. Okay, so the only possibilities are to have, and forget about the signs for a moment, a 5 here and a 1 here, or to reverse that. If I multiply 2x times 5, I'm going to get 10x. That is too big, so it's not possible. So we'd have to put a 5 here and a 1 here, because this would be 5x, okay? And then this would be 2x. So that would work, I just got to get the sign right. And basically I want 5x to be the larger one, so I want a plus sign here and a minus here, right? So the outer would be -2x, and the inner would be +5x, so this would be your correct factorization. Now, what I'm going to do here is multiply it by, I'm going to flip this guy. So this is going to be my numerator, okay? My denominator becomes my numerator. So let's factor this guy. We'd have an x here and an x here. And so what I would do is look for two integers whose sum is -4 and whose product is 3. So you can go ahead and do -3 and -1. So -3 and -1. And then this is over. Again, this numerator here is now going to be the denominator here. So I'm going to factor this guy. So give me two integers. I'm going to put my x here, my x here. Two integers whose sum is -2 and whose product is -35. Well, you could do -7 and +5. So -7 and +5. Okay, so let's scroll down now. Again, all you have to do is just flip the second fraction, or it's flip the second rational expression. Everything else is just the same, right? You're just multiplying, so you're looking to just cancel stuff. So I can cancel this guy, x minus 7, with this guy, x minus 7. Those are common factors. I can cancel this factor of x minus 1 with this factor of x minus 1. And then, can I cancel anything else? Doesn't look like it. So in this case, we actually need to multiply. Now I'm going to tell you two different ways you can do this. In every case, you are allowed to just say something like x minus 2 times x minus 3. So those two quantities multiplied together, and leave it as it is, okay? Some teachers will tell you to multiply the numerator out and leave the denominator factored. Some want you to have everything factored. You just have to check with your teacher to see what's required. Down here, I'm going to do this 2x plus 5, that quantity, times x plus 5, okay? And just for the sake of completeness, let's go through the process. And we're going to multiply everything. So x times x is x squared. The outer would be -3x. the inner would be minus 2x, and the last would be plus 6. So this would be minus 5x here. So minus 5x and then plus 6. This is over. The first would be 2x squared. The outer would be plus 10x. The inner would be plus 5x, and the last would be plus 25. So if you combine the like terms, you'd have plus 15x here. So basically, you could write this like this in the factored form, or like this where you've multiplied it out. Either way is an acceptable answer. All right, let's look at one that's very, very tedious. This is just a lot to do with factoring, and basically you have to be good at factoring to be good at this guy. So when I look at this problem, I see multiplication and then I see division, okay? So basically you want to turn this into one long multiplication problem. You're just going to flip this guy right here, okay? So basically what I'm going to do, I'm going to try to fit this all on the screen. So x squared minus y squared, we know this is the difference of two squares. So this is x plus y times x minus y, okay? So you can factor that. Then this guy right here, this x minus y quantity squared, remember, I can't say this enough. You cannot distribute that in. You have to expand this. This is the same as having x minus y times x minus y, okay? Now, it turns out that if you run through this, you're going to get this, right? So this is the expanded form, and this guy is the factored form. Really, you'd write it like this, okay? So let's see what we need to do with this before we expand it. We'll put x minus y. I'm just going to put quantity squared. So I'm just going to leave it as it is, okay? Then this guy right here, up here, we cannot factor this. This is -1 and this is +1, okay? So can you give me two integers that sum to -1 and have a product of +1? No, you cannot, right? It's not possible. So I'm going to leave this one up here as is. So x squared minus xy plus y squared. And this is over. This guy down here, which we already know is going to factor into this, right? If you expand this, you square the first guy. So that's how I get x squared. Then it's minus 2 times the first guy times the second guy. So I get minus 2 times x times y. Then it's plus the last guy squared. Okay, so this factors into x minus y quantity squared. Then I'm going to multiply by, I'm going to flip this guy. Now, this guy right here is the sum of cubes. So this guy is something you should remember how to factor. It's really convenient to remember how to factor it. I don't know if I can fit this all on the screen as of right now. So let me just write this in unfactored form. And then I'm going to go to the next screen down and we'll see if we can get this on here, okay? And then this guy right here, this is x minus y to the 4th power. So we're going to be able to cancel some stuff right now. That's going to give me some space. So you'll see here that you have x minus y, this quantity squared, basically multiplied by x minus y, this quantity squared. So you could write this out as x minus y times x minus y times x minus y times x minus y, okay? And you could write this out as the same thing. Realize your rules of exponents. You have the same base here. This is your base, okay? This is your base. So really, this is x minus y to the 4th power, okay? So those guys combined would cancel with this completely. This would cancel with this and this, okay? Again, if you wanted to write this part as x minus y, and this as x minus y times x minus y in each case, then you'd see that you have 4 of those, and you could expand that out to exactly this, and it would all cancel, okay? So that is gone. Now, the next part here, to go any further, let me scroll down a little bit and get some room. I'm going to write x plus y times x minus y. And then times, you have this x squared minus xy plus y squared. And then I'll put times, you'll have this 1 over. Let's go ahead and factor this now. So from my special factoring formulas, this is going to be x plus y. That's the first one. Then times, it's going to be exactly this. So x squared minus xy, and then plus y squared. So now what I'm going to do, I'm going to think about this again as a factor. So I'm going to cancel this with this, and then I'm going to cancel this with this. And really all I'm left with now is this x minus y, okay? So you can see on this type of problem, they just want you to really know how to factor in order to go through and just cancel, cancel, cancel until you end up with something very simple with just x minus y as your answer.